All right, this is my submission for the Math 220 video project. For this project, I decided to take on the GPS problem from the first chapter. It states, given the following 3 points in the plane A, B, and C, and the distances from each point to a fourth point P, find the XY coordinates for the point P. And so you're given a table labeling each of the fixed points, their location, and their distance to P. And so what these fixed points represent in the problem are GPS satellites, and the distance to P is a circular radius in which P can be found from the satellite. So when you have one circle, you have an entire circular radius that P could be within. And as you get more fixed points introduced to that, you then have intersecting circles, and that triangulates the position to where P can actually be. So, knowing that these satellite fixed points can be represented using a circle, we set up the general equations for each circle using the data from the table. Here you can see I just have the general equations for the circle as well as the corresponding relevant center location and radius. Um, and then I'm going to want to use FOIL to expand these general equations because as they're not linear, they have squared terms. And to do any linear algebra methods, we need purely linear functions. So what I do here is I FOIL out the general equations and expand them. Um, so that we can manipulate them to remove the squared nonlinear terms. So once I expand, I continue on. I take the constant of the radius and I bring it over to set them all equal to 0. This just allows me to do the math a little bit easier when I'm doing my manipulations. And so the reason we want to get rid of our nonlinear terms and do it this way is the resulting linear equation will give you a distance relationship between the two circles, and it narrows down the potential location of point P to a line. And then once you have two of these distance relationships between two different circles, you can find the point where these two lines intersect, and that will give you the exact point P. And so in my case, I did circle B minus circle A equation, and you can see all the steps here. The nonlinear terms x squared and y squared cancel out, and we're left with this big old jumble mess, which simplifies down to this equation here at the bottom, labeled 1. We hold on to that for later when we end up simplifying for what we want to put in our matrix. And then again, we just do circle C minus circle A. Uh, you see the nonlinear terms cancel out. Again, still a pretty messy equation left over, but we take this and we'll um, plug in our values, simplify, and then use this for our matrix. So here's where we actually get to the linear algebra portion of the problem. So we have these two equations that linearly represent where P lies in the space. We have this data set that tells us the values for A, B, and R in each of our equations. You can see that um, circle A corresponds to A1, B1, R1, circle B, A1, A2, B2, R2, and so on for circle C and number 3. And so method I chose to use here was I simplified all of my expressions by plugging in the values where they go. You can see the first equation simplifies down to negative 80x plus 80y equals negative 3200 0.3979. And then I do the same thing for the next equation. I plug in all the values present, and that simplifies down to negative 160x minus 80y equals negative 20,800.162. And then once you have those two equations, you can set them up in a 3 by 2 matrix and get the reduced row echelon form to solve for your terms of both x and y, or your variables both x and y. And so this is just kind of a explanation of how I set that up in a TI-84 calculator. So what you're going to want to do for that is hit second matrix edit, and it doesn't particularly have to be matrix A, but in my case it was. You're going to enter the values as they're seen to the left here. First column representing your X terms, as you can see. Second column representing your Y terms. And then your third column representing your constant that your equation is set equal to. And then you're going to quit out of that screen, then do second matrix again. Use the arrow to go over to the math tab, select the RREF or reduce row echelon function. Then you'll be sent back to the main calculator screen. You'll hit second matrix and then select whichever matrix you filled these values into. And then once you hit enter, you should be returned with a matrix that looks like this lower one in reduced row echelon form, where this is telling you the corresponding value of x and the corresponding value of y that makes both of these equations true at the same time. And you are given the XY coordinates for point P 100 and 60. All right. And that's pretty much it. Thank you for watching.